Hi everyone, today I want to show you how to fit ANOVA with LCD and bar graphs with standard error bars for comparison using least significant difference LCD. In this video, I will show you how to fit analysis of variance model to make comparison of treatment groups or replications using least significant difference LCD test and plotting bar graphs with standard error bars. And I'm going to show you how to place alphabet from mean of LCD test on top of each of these error bars. I'm going to use two-way ANOVA technique to fit a model for the dataset provided in this example. Now this is my data example. Comprises of 4 variables: the status, the drug, the sex, and the biomarker. Most of the time, before I import my dataset, I used to use these 3 functions to clear my global environment, to clear my console, and to clear all the graphs that I've made before. Now I can use this to import my dataset. After importing the dataset, I can decide to see how my dataset looks like, and I also want to see the structure of my dataset. The variable status, the drug, and sex should be in a factor structure, but here we can see that it is in character structure. Then I will use the following codes to change it from the character structure to a factor structure. Now let me check the structure of my dataset again. It has been changed from the character structure to factor structure, which is very good for what I'm about to show you now. Then I attach my data. Fitting analysis of variance model. We can actually use either AOV or LM to fit the model, but you can only use AOV if there is no missing values. If you check our dataset, we will see that there is no missing value in it. Therefore, using AOV for our model is a good one. If there is a missing value in the dataset, it is advisable to use LM from the package NLME. I will run the two to see if there's any difference or similarity between the two. Now so this is for the AOV, the ANOVA. We can see that now. Then I can also run for the LM to see if there's any difference between the two. Yeah, the two are the same thing. According to this result, the two are very the same. Now the next thing I want to do is to show you how to apply LSD on the variables that we are having. Now the first one I want to show you is how to apply it on the variable status. But before then, to apply this test, I have to load LSD test function for multiple comparison of treatments. I'll load the package agricoli. Then I use the following code for me to get the LSD for the status. The function requires some argument. In y argument, which is equal to the biomarker, you can specify model or use response variables, and our response variable is biomarker in this case. In treatment argument, specify the first factor variables, which is the status variable. You can also set the value for df error by writing df.residual its model object after $sign by using this. Then we can also set the value for error mean square by dividing ms error and the variance of the model object with residual degree of freedom. I shall use the default value for alpha argument that represents the 5% level of significance. In this method, the argument p.adj for adjusting probability value, I shall use the Bonferroni, which is the most used method. I will set a logical value for group arguments to specify grouping of treatment means. To set that for console argument to print the output. Now, all these things, then I will run for the variable status. Now, for the variable status, it have the alive, the transplanted, and the dead, and this is the group for it. Now, the next one is for me to run for the drug. I'll use the same. I'm going to do the same to drug like I did for the status. Rest of all the arguments will remain the same. Then for the drug, I run the same thing. Then I will do the same thing for the third variable, sex. Then I will do the same thing for the interaction terms, the status, and the drug. Also, the interaction term, the status, and the sex. Then for the drug and the sex, the interaction between them. Then the interaction of status, drug, and sex. So these are the results of LCD applied on the interactions. The next thing to do for me is to calculate the mean and the standard error. Before I do that, I'll have to load library dplyr for grammar of data manipulation, and I use the pipe operator for connection. In summarize function, the object for mean and standard error will be created. I will use the print function to display the result for this object. I do this for all the variable terms created. So I run my package. Then the first thing is to create the mean and the standard error for status. I print for me to see, and then I will attach. Then I'll do the same thing for drug. Then for sex, drug status and drug, status and sex. drug and sex, next step is to arrange the treatment group in the original order of treatment rather than rank order of LCD test results. This will help me while adding alphabet from treatment group in the same order as the order of treatment in the plot. I'll connect this group component from LCD object with the group _by function and arrange function for the same components using the pipe operator for connection. Then I'll print the function for this object to show the original order of treatment. So the original order of groups for lettering. So when I print it, give me this. I'll do the same for everything. Then after this, the next thing is to create plot objects. Let me start to display the main and interaction effects using the grammar of graphics, the ggplot function. This will require me to load the package ggplot2. Then I load the package. Then I'll create an object P1 using the grammar of graphics function. Now this is how I'll create my object. I will do this step by step for you. So the next thing is for me to add error bars on it. Then the next thing is to change the main title if you want to, and if you don't want to, there's no problem. Then adding the lettering from the test applied. Now I plot. So this gives me this is the lettering to show the comparison between them. Then I want to do for the second plot, that's for the drug, but I can plot everything together. It gives me this. So then for the third, and plot everything. Then the same thing to the fourth graph. This is for the interactions. The plot for status and sex interactions. You can see this very well. Then for drug and sex interactions, then for the last one, we have this. This is between the status and the drug and sex. This is the simple way of plotting LCD test. I hope this tutorial will help you to understand how to visualize the bar plot for the main and interaction terms. Feel free to subscribe and like this video.